morning, everybody. This is Carl Griffith, Director of Emerging Technology at Graybar, and we're just glad to have you online today for our G2 Talk seminar series where we're going to discuss IEEE and TIA Next Generation Fiber standard updates, particularly as it applies to the data center. So we're just excited as could be that you're with us today. Before we get started, I think it's important for us to discuss a little bit about what Graybar is all about. So here's our mission statement. Graybar helps our customers power, network, and secure facilities with speed, intelligence, and efficiency. In this particular case, the facility is a data center, and that's exactly what we're going to talk about today. Speed, intelligence, and efficiency inside the data center. And we're going to get some great information today that can be all helpful to all of us as we work in and around data centers. Before we get started, I wanted to remind you that this is an interactive presentation, so there is Q&A. And if you'll check your screen, you'll see an area where you can, a chat box there where you can type in your questions. We encourage you to go ahead and type questions in. We get them on this end, and when the presentation ends, we'll go over those questions and we'll have a Q&A at the very end. So I encourage you to type your questions in. The first 50 people that joined us today and are on the webinar and watching it will receive a cup of coffee courtesy of Graybar, and we're glad to do that. The way you'll get it is with an email. An email will be sent to you, and there'll be instructions on that email about how to take it to a very large national coffee chain, and you can get a cup of coffee on Graybar, and we're glad to do that. The other thing I'd like to mention is this particular webinar earns some Bixby credits. So if there are people online that are affiliated with Bixby and would like to get their Bixby credits, everyone on this call will get an email from us with instructions on how to get their completion certificates. So that will happen immediately after the presentation today. Our presenter today is Gary Bernstein. He's an RCD, and he works for Leviton, and he works in the Fiber and Data Solutions Center at Leviton. He's a Senior Director of Product Management. I've known Gary for quite some time. He's a subject matter expert in the data center, and he participates in the standards business. So he's an expert on the topic that we're giving today on standards from IEEE and TIA as they apply to 40 and 100 gig in the data center. So I'm going to pass the baton over to Gary. Thank you, Gary, for joining us, and we're looking forward to your presentation today.
Carl, thank you for the introduction. I appreciate it. Morning, everybody. I am pleased to be here today, and I've thrown up an agenda what we're going to kind of go through today. And first off, I'm going to give an overview of the IEEE 802.3 BA, the current 40-100 gig standard. Many of you might be familiar with this already. Some of you might not. I'm going to give you just kind of an overview and update on that. Next, some of the changes and updates, recent developments in TIA and 568 standards relating to the 40-100 gig. As well, I'm going to go through and show you some examples of the equipment, the active equipment that's being used today, and some of the new stuff that's coming as well, and the equipment, the switches, the transceivers, and so forth. And then lastly, we never stop with developing new technologies and bandwidth requirements out there. And so a little bit of an update on the IEEE side, what's on the roadmap, what's coming up next, and I'll go through that in a moment with you. So first off, again, a little bit of a summary on the 802.3 BA standard, and this is really just a summary of the cabling media, so the approved cabling media that's in the standard. 40 gig at the top and then 100 gig below, pretty similar between the both. But I'll just kind of go through on the single mode, 40 gig single mode side, that's up to 10 kilometers. Single mode does utilize duplex transmission, so it's two fibers, and the multi-mode uses parallel optics, and I'll go into that in a little more detail on the parallel optics. But under multi-mode, it's 100 meters on OM3 and 150 meters on OM4. There's some perceptions that OM3 does not support 40-100 gig, and obviously that's not correct. So either one, OM3 or OM4, will work. On the copper side, what is in the standard is basically a direct attach twin-X copper assembly. So it is up to 7 meters in length, Again, it's a shielded twin-X cable with QSFP connectors on both ends at direct attach. So for the 100 gig, it's pretty much the same, except you'll see that the single mode, there is a longer reach option. So you see here I say an LR, so LR stands for long reach at the 10 kilometers and 40 kilometers extended reach for single mode as well. So again, these are really from the existing standard, and that's what's out there right now. The next I want to go in a little bit more detail on the multi-mode side for parallel optics, because that one is a little bit different, and just so everybody understands. So the channel requirements are spelled out. So I'm talking about just the optical cabling channel. Right, for OM3 and OM4, the channel loss as well as connector loss. So channel loss for OM3 can be up to 1.9 dB, and max connector loss 1.5, and then OM4 is a little bit less, 1.5 and 1 dB. So it is important just to understand that as you design your network, right, and understand how many connections are needed within the channel to make sure that you meet the max loss budget. If you compare that as an example to the current 10 gig, it's at 2.6 dB. So again, you can see it continues to go down, the loss requirement. As highlighted there below, the max per connector, this is per TIA, still specifies a .75 insertion loss. The reality is most manufacturers are doing much better than that. So you're typically able to get more connections within that channel, which adds flexibility in the design. So a little bit more about the MTP lane assignments. So what we're looking at here is really just into the front of a transceiver or an end face of an MTP connector, right? So you take a look at the top here. This is representing, again, like a 12 fiber connector, and for 40 gig first, the term is 40G base SR4, and that does use 8 fibers. So 8 out of these 12 are being utilized for 40 gig. You'll see the transmit, 4 receive, and then the 4 in the middle are not being used. So really, it's important as you go through this and as you design for migration to make sure that you plan ahead and you're not losing out on any fiber plant, right? You want to maximize and utilize as many fibers as possible. On the 100 gig side, in the standard, there's really a couple options laid out. It's either 2 12 fiber connectors, or the recommended one is a 1 24 fiber connection. So if you see here on the 12 fiber options, you've got basically one connector is transmit, the other one is receive, and only 10 out of those 12 fibers are being used. So 10 channels, right, 10 gig per channel gives you the 100 gig. On the 24 fiber side, you've got 20 fibers, right, 20 out of those 24 being utilized. So just to go in a little more detail, just to show you a little closer. So on the 100, this is just on the 100 gig side, what that looks like from a transmit and receive standpoint. Again, you're going to have 2 different connectors. So this is just showing 1 through 12 on one connector and 1 through 12 on another. And you'll see that it goes from transmit to receive on one connector and then transmit back to receive on the other connector. For the 24 fiber option, so this is really representing one complete connector, 1 through 24 possible fibers in there. The middle ones and the end ones are not being utilized. Again, all in one connector. If you see on the other picture on the side here, if you haven't seen a 24 fiber MTP connector before, it is done in 2 multiple rows within the connector, the ferrule. So there's a row of 12 and another row of 12, so for 24 fibers in that connector. Next, I wanted to go into the equipment side a little bit. And there really is quite a bit of equipment on the market today and a lot of development that there has been over the last couple of years. So on the 100 gig side, most of the leading manufacturers, Brocade, Juniper, Cisco, and others, all do have line cards available. These are just representing some of their different equipment, Cisco, Brocade, and Juniper, that would have 100 gig line cards available. Typically right now we're seeing that being used coming in to the data center on the client side and then potentially with tie lines in between core switches. Next on the 40 gig side, this is really where there's been probably much more development and introduction over the last probably 12 to 18 months. A lot of different things coming out. So go through some examples here. Extreme Networks has their top of rack and Black Diamond core switch available. Cisco did introduce their Nexus 3K top of rack switch with 40 gig capability. In addition, I didn't add it on here, but recently Cisco did or does now have for their Catalyst 6500 series a 40 gig line card available. That is probably the single most common switch on the market today. So that is out there as well. Blade Networks, IBM now with their top rack switch. So just to go into these a little bit more, if you look at the last photo on the bottom, the Blade IBM photo, the connections on here. So we've got 48 10 gig ports. These are SFP plus connections. And then on the side, this is where our uplinks are, right? These accept QSFP transceivers, which is for your 40 gig uplinks. And that's the same if you look on the Cisco one, and you'll see that on a lot of the other top of rack switches, edge switches as well. A few more examples here. Force 10 does have their E-Series as well as their top of rack switch with both. The other one I did want to point out, I didn't add this in here yet, but in addition to the SFP plus 10 gig ports, we are starting to see 10G base T connections now as well. So it would have 48 10G base T as well as the 40 gig uplinks on there. Arista has quite a few different options out on the market. Their 7050S and the 7050Q, I wanted to point this one out. It's a little bit different. You'll probably see more like this in the future. So this doesn't have any 10 gig ports. So this isn't SF. It's hard to see by the picture here probably, but these are QSFP ports, all the server ports, not SFP. And so what that means is it's a 40 gig channel, or it can be converted to 4 10 gig channels using conversion right on your cabling. What that relates to then is that would be up to 64 10 gig channels in that 1U top of rack switch. Again, more and more density we're seeing out in the market. Here's an example of where the switches are being utilized. This is from Extreme Networks on what they show on the recommendations for using the 40 gig architecture. So on the bottom here, these are the black basically representing server cabinets with 10 gig connections in there. Those connections are going up to edge or access top of rack switches, whatever you want to call it. They're all pretty much the same thing. Then from there, this is where your 40 gig is being, right, is going from that edge up to the core in the aggregation layer. Your 40 gig uplinks, and typically you're going to have redundant paths going to those different core switches as well. We'll say, right, so today that, again, at the 10 gig server, there is some market estimates that from a server standpoint that by the end of 2013 there will be 40 gig servers on the market. Haven't seen those yet, but that'll obviously even drive the demand and the bandwidth requirement even more as you go up the architecture within that data center. A couple other examples as on equipment. The density, as I mentioned, continues to increase. Here's an example up on top from Mellanox, top of rack switch. This one has 48 SFP plus 10 gig ports on the side here, and 12 40 gig uplink ports. Instead of the 4 on the other ones, this one has 40, and that's really to fully maximize the 100% bandwidth within that switch. So again, you know, it's just more and more fiber that's needed, and you need to keep it in mind as you design your network to migrate. Another example is the Extreme Black Diamond switch. They have a blade now with 24 40 gig ports in there. You load that up in their core switch, and in 15U get up to 192 40 gig ports. So next on to the transceivers a little bit. I'm going to go through the 40 gig and then the 100 gig side. So on the 40 gig side, there's really two options that are out there. A CFP which stands for C-form pluggable, and that is used for single mode. The LR4, you see I mentioned that before, that's highlighted there just for single mode long reach. 4 is the 4 channels. And then QSFP is a quad small form pluggable. And again, the abbreviation in the topology is SR4, so short reach 4 for multi-mode for 40 gig. So if you take a look on the side over here, the CFP transceiver, this one actually, again, it uses 2 fiber connections. This photo is showing a Sam Charlie connector. It also is available in an LC Larry Charlie connector footprint as well. On the QSFP, you can see, so just to reiterate, right, as you see here, the MTP or MPO connects directly into that transceiver, into the switch. See from the picture below, it's a photo of an actual, right, one of the switches with those 40 gig transceivers in there, and the MPOs, MTPs plugged directly in there. Next, on the 100 gig side, the transceivers there are also a CFP option for that, and that can be in multi-mode or single mode. So the single mode being the LR4, the multi-mode SR10, so the 10 is 10 channels, right, of 10 gig. And then the CXP is another option on the side over here. You can see this one's a little smaller. If you look from a size standpoint, a CFP is about 3.25 inches wide, versus a CXP is just under about an inch wide. So again, more density, higher footprints is what you're going to see moving forward. The one on the CFP, if you look at these a little closer, this one, it's hard to see on this picture, but you see 100 gig, and it says SR10 on the bottom here. So that is one MTP or MPO connection, right, as we talked about before. Another one that's something relatively new that is pretty interesting is a new 40 gig extended reach transceiver. So this is what we call a QSFP Plus short reach transceiver. It does exceed the 802.3 BA requirements we just went through. But this was the key points about this is the reach again. So it could be 300. It could go 300 meters over ohm 3 versus the 100 meters in the current standard, or 400 meters over ohm 4 versus the 150 meters. This is backwards compatible to 10 gig as well. One thing I just want to, so Leviton did some testing and to validate this claim. We worked with a large end user that really wanted to evaluate this. And so we laid out basically some common channel configurations with the switches. It was some beta switches that were being used, and laid out the 300 and 400 meter different channels. The customer ran data packets over that network and made sure that there were no drop packets or there were no errors without the channel. And bottom line, everything passed fine, and it worked well, and the customer was happy with that and was going to move forward with this option. But you'll see, right now I think the only one I've seen is Arista that does actually have this out fairly recently, Arista Networks. Avago has the transceiver, but obviously they're working with different switch guys, and I think most of them will probably be offering sometime this year. Bottom line on this is that multi-mode can support 40 gig beyond 150 meters. It is a lower cost option than the current single mode links, like the LR4 links we've talked about, and it will likely impact future network designs as you go forward. So now on some standards updates as well. So on TIA side first, so this is an addendum. This is a little while ago, but not sure if everybody is aware of it or not. So this was back in December 2011. And this is to C.3, which is the fiber component standard. And really what was done was adding the components in there for array cabling, right? Array or MTP connectors, MPO connectors, to allow to convert from duplex to parallel optics. So the standard we just talked about on the IEEE side. It does use 12 and 24 fiber connectors to be able to do that. And these are just a couple examples. I'm not going to go into a lot of detail, But these are a couple examples. So in this case, it's basically going from two 12 fiber connectors to one 24 fiber connector in this case. And then also this is just showing another array cord, a straight through array cord, an MTP to MTP patch cord to be able to support 40 gig or 100 gig. In this case it's 12, it's showing 12. So that was done on the C.3. The other recent update, this was back in August of last year, and this was to the C.0 standard, so it was an addendum to the main standard, which really goes through the overall channel requirements, optical fiber cabling. And this really added the polarity requirements and clarification about these channels. So for the standard, the approved polarity methods, method A, method B, and method C, to convert from duplex to parallel optics. And here's a photo here of just showing an example, right? You've got whether it's for the trunk as well as the adapters, as well as the array cords that are used and need to be used to maintain polarity throughout that channel. Again, done for A, B, and C. Now on to IEEE. I wanted to talk a little bit about that and what they're doing. So a little bit of background here. First, there was a study group formed back in September 2011 to really look at next gen, and the goals of that and the purpose of this group was to look at how do we get an installed cost of 100 gig systems, how do we reduce that. A study group's goal is to establish objectives, 5 objectives for the standard, and they did set that agree upon that in March of last year. So after that, back in August, I'll go through the timeline in a little bit here too, but in August, IEEE did approve a task force, so it is the 802.3 BM, and so this will be an amendment to the overall 802.3 standard. This will address 40 and 100 gig specifications and parameters. It'll use 4-lane electrical interface. I'll go into a little bit more on that in a minute. And it's for multi-mode as well as single mode. On the single mode side, it's also going to address a 40 gig PHY beyond the 10 kilometers, which the current standard does not today. So really, this is a summary of the objectives and the criteria within the BM standard. Key objectives: reduce power, cost, and increase density within these applications. So if we look at the criteria as defined by IEEE, proposed PHY would use a 4 by 25 gigabit per second electrical interconnect lane. So that's instead of the current one is 10 gig per second. So 4 by 25 versus 4 by 10, or the current 100 gig is actually 10 by 10. This is over multi-mode as well as single mode. So this part is what is new. So if we go back again, the current standard for single mode uses 2-fiber duplex transmission. So for this next standard, it will include single mode for parallel optics as well. So multi-fiber connectors for single mode will be an option as well as the multi-mode. The 40 gig we talked about over the 10 kilometers, and then also proposed the PHY, the multi-mode would use 8 fibers instead of the 20, as I just mentioned, for the SR10. So just to show you what these would look like, what the applications would look like, and their names. Some of them are TBDs, but this is what it'll look like today. So on the 40 gig side, over single mode, it would be a 40G base ER4. On the 100 gig, for up to 500 meters of single mode, 100G base NR4. For 100 meters of multi-mode fibers, it would be the SR4, 100G base SR4, right? And then on the other shorter reach for 20 meters on multi-mode is 100G base UR4. Some terminologies, these might change a little bit, but if you see these, at least you know what we're talking about now. Here's, I mentioned a timeline, just a quick, give you an idea overall. If you could see this, it might be difficult to read throughout, but just to give you an idea, it starts out, this is from IEEE, and this is straight from one of the IEEE meetings. It starts out with a call for interest. a CFI they call it. At the beginning, it goes through kind of a long process of the objectives, the task force, the drafts, and so forth. But really, it's we're at right now in the task force stage, and the estimate is that the standard would be out in roughly in the Q1. It shows standard right here in March, so roughly Q1 of 2015. Still, a few years away from this. Next, I want to just more about transceivers. So on this next gen, there are folks already working on transceiver options to validate that it can work and what can we do. So that is still TBD a little bit, but the likely options are a couple here. The CFP2 or CFP4. These are really similar to the CFP we looked at before, but just smaller footprints of those. You look on the bottom here. Is showing a CFP4, a quad orientation, so there's actually four different transceivers, and these are about less of an inch, a little bit less than an inch in width. The other option is a next gen of QSFP. It would be the same footprint as the current QSFP Plus, but higher performance capability there. This on the side here, I just want to show you as an example of some of the development that's going on. You see on the side here is an existing CFP transceiver going to this other, the smaller size, the smaller footprint, which is a fraction of the size. The other point on there too is the power goes from the current 30 watt on there on the LR4 to a 2 watt. So again, a big change in the power as well as the footprint size. So next, believe it or not, they're beyond 100 gig. What's after that? And there has been a lot of discussion and already early work done on this, and it has been settled on right now likely to be 400 gigabit Ethernet. There is a call for interest, as I just talked about, scheduled at the upcoming March meeting for IEEE, and so that will be started to talk about. But some of the equipment manufacturers and the transceiver manufacturers have already done some, obviously, early assessments to confirm that it's viable and so forth. In addition, on this chart here, I wanted to point this out. This is kind of an interesting chart, and this is from IEEE. And it was actually done. It's a bandwidth assessment study that has been done, and this was actually done early in probably 2007, initially to develop the target level for the current 4000 gig standard, which we talked about. So let me just to walk you through what it's shown here. So on the vertical axis here, this is rate megabits per second, going from 100 megabits all the way up to 1 terabyte. And then just history from 95 up to an estimated forecast of 2020. And the red line here is the core networking history, so the switches, and then the purple line are the servers, right? Is the server I/O and the history. Interesting, points on this. On the network, on the switch side, history has shown that the bandwidth requirement doubles every 18 months. And on the server side, that it doubles about every 24 months. So really, they kind of tracked out and measured this. And when they did this back in July of last year, IEEE published a report, and it was really to look at what do we need for beyond 100 gig. What is the next bandwidth requirement going to be and forecast? So if you take a look at this chart, a couple of things. You look at 2010 point here, right at the 100. It lands at 100 gig. For the core networking switch, which is kind of where they targeted, obviously, the current BA standard. But you look down even beyond at 2015, your network switch is already getting close to 1 terabyte. So it's kind of in between the the server I/O at the 4050 level and the network switch at the 1 terabyte. So again, this was really just validation, and you could see where the 400 gig requirement has come from. Okay, hopefully that helps. So really, just to summarize, I haven't talked much about Leviton stuff here at all. It's really about the equipment and the architectures, but I do want to just kind of highlight and summarize, a little bit about Leviton's solution. We're very close to the equipment guys as well as the standards bodies, as we've talked about. We do have a 24 fiber system that will support either the current BA standard or even the BM requirements. Some folks have talked about, well, it's going to be 4 by 25 gig. There's still, if you think about it, it still makes sense because there's a backbone standpoint. You might not be connecting with 20 fibers anymore. You connect with 8, but it's basically the same thing as the current 40 gig standard. Leviton's Unity system will reduce the cost of ownership, as well as it does make sure you utilize the fiber as much as possible throughout the channel. Again, just keeping that in mind as you plan your networks, that you're going to lose some fibers if it's not planned out correctly. And really making sure that you have an easy migration path going forward. That's really the simplicity of it. And that is pretty much it. Fairly quick. So I will open it up to questions for you guys. And if you want to you could go ahead and type in questions on the monitor there, and Carl will go ahead and summarize for us.
Thank you, Gary. That was an excellent presentation. We do have some questions. The first one, if you could slide the deck back to slide number 23. Robert has a question about the distance there in slide number 23. I think it's back a little bit further. One more. That slide right there. He's wanting to know in slide 23, is the distance 40 kilometers or 40 meters?
No, it's 40 kilometers. It is 40 kilometers, yes.
It is 40 kilometers for the 40G base ER4.
Uh-huh. Yeah, because the 10 kilometers is already on the existing standard.
Okay. All right, that's great. And then we have a couple other questions I want to throw in here. What's the price delta from a multi-mode to single-mode 100G transceiver? Do you know what that might be?
Yeah, I've looked at it. Just in the market, there is some variation. So, and that's why the reality is a lot of people are going towards the multi-mode route right now, because so on the 100 gig side, it's probably about 30 times more from a single mode an LR4 versus a multi-mode transceiver. Just the transceiver we're talking about. The 40 gig is not just as a reference point, the 40 gig, there isn't as big of a delta, and that one is probably closer to eight times for single mode.
Okay. Evidently, Robert likes the answer at 40 kilometers because he's indicated here that could help him in some campus environments to get out to 40 meters. So that was a good thing here. Greg's asked a question about 40 gig copper. That there's some rumor that 40 gig copper could go up to 100 meters, and we've heard that. Is that true or not? I could reference what I've seen, and we have folks that are pretty actively involved in that. But basically, there is work being done, I know, within TIA and IEEE on a next-gen copper standard over twisted pair. So, because the current standard, as we talked about here, only utilizes twin-X direct attach cables up to 7 meters. So the twisted pair standard, that's still in development. The little that we know is probably that it will be shielded. It'll likely be limited to 40 or 50 meters in that distance realm. Okay. When we're looking at these, Tom asked this question, when we're looking at these connectors, whether it's the 12 version or the 24 version, and we have those extra spaces where fiber is not being utilized, has there been any discussion about how fiber can be utilized in those extra spaces, that unused fiber for some other type of connectivity? Is anybody talking about those spaces in there to do maybe some other kind of communications or connectivity?
That's a good question. There really isn't. I mean, at this point, I think that's why one is you want to just to maximize what you can. You know, you could potentially split out. There might be some ways just to split from 10 gig channels, right? You know, utilizing for 10 gig or 40 gig. There are ways to do that to mix that up and fully maximize the use of fibers. But beyond that, there's not too much else that's being looked at.
Okay. All right, I just want to remind everybody while you're online here, if you'll type your question into that chat box here, we'll get it on this end, and we'll get Greg to answer those questions as Gary answer them as they come along. Here's another one. Upon completion of the presentation, Perry asked this one, could I print out the presentation from my records and use it for training personnel? I can tell you that the presentation, Perry, and anybody else online, is archived on graybar.com. So if you go to graybar.com and click on events, up there you'll see an archive for these G2 Talk seminars, and you can review this presentation and look at it again. I'm going to refer to Joan and see if we have a PDF of the presentations up there.
Yeah, we'll also have an on-demand version that will be sent to you by email after the presentation today. So you'll be receiving a link to that.
Okay. As far as having the actual slides themselves, I don't know the answer to that, but if you'll send me an email, carl.griffith@graybar.com, I'll get with Leviton and see if they want to share them or not. But you can review the presentation and the stuff's up there. Let's see what else we have. One of the, this is just, Robert brought this up in terms of these extra spaces that are inside these MPOs, MTPs, is that it might be helpful in order to allow monitoring if the cable were connected or disconnected for an alarm situation. So there might be some kind of security thing about letting people know if it's been, which connector has been removed or not. But that was a suggestion from Robert that those extra fibers could be used for some other purpose.
All right, thank you.
Corey has a question here. The connectors with 24 strands are terminated how? Are they fusion spliced? I don't think my Unicam kit will work. There was an attempt to try to make a field terminated MPO, but I think it failed. What choices do we have for field termination?
Well, on the MPO or MTP, I mean, the reality is, especially at 24, I think it'd be very difficult to do in the field. That there is, I do know that there are, there's mash fusion splices, right? So you could do a 12, whether there are products to do that. But the reality is, so we recommend doing them in the factory. It is a controlled environment that's consistent and make sure that you'll have a quality product. On the 24 side, again, it's not very easy, and you need to make sure that the proper procedures and the tools are in place. Leviton has done a tremendous amount of work actually on that, and have the right polishing equipment and the cleave tools and so forth to make sure that it's consistent cleave. That's probably the best way to go with the MPOs and MTPs right now.
We tend to agree with you. We seem to think if we can plan in advance and get the lengths, it's a lot easier to have these trunk cables terminated in the factory and then delivered based upon the schedules that are provided with the proper lengths. However, I can tell you that I have seen MPO pigtails. So I can't remember who had them, but I've seen some pigtails that you can splice.
That is another option. You could fusion splice those pigtails in.
In the multi-mode 40 gigabit new standard, we'll be asking for 8 fibers. What will be? I can't understand the question. What will be Gary idea for? What's the idea of pushing 24 powers to MTP solution? Do you know anything about 8 fibers at 40 gig in multi-mode?
Yeah, let me see. Is that question? I think what they're getting to is about the 24 fiber, using that still.
Yeah.
Really, what that would be then is, I mean, you look at that. When I talk about 24, I mean that's that's throughout the channel, right? So your backbone cable. So for example, my trunk cable, if that is 24 fiber MTPs on there, you're going to then split that out and put whatever is required on both ends for that connection into the equipment. So whether it's, today it's an LC jumper for duplex, or it's an 8 fiber MTP to MTP connector, or a 20 fiber connector today, it'd be the same thing. It'd be just like a 40 gig today. So instead of it being a 40 gig 8 fiber, it would be a 100 gig 8 fiber in 3 years. So that's really, and it allows you, you don't have to replace that cabling going forward.
There was a question about the terminology MPO, MTP. Both you and I have used it interchangeably through our dialogue and in the presentation. The person who wrote the question thought they were the same and wanted to know why there are different names.
Yeah, just briefly on that. So MPO is the generic name, multi-push-on connector, and MTP is actually a trademark name owned by a company called US Connect. So it's basically, the MTP is just a variation of the MPO. There's some internal components that are a little bit different, the spring, the shape, a few different things that I'll say. So the footprint is the same. They are interchangeable. There is an IEC. There are IEC standards that define what that footprint is, just like an RJ45, right, for copper. So that's, you have to, various manufacturers use different connectors. Leviton personally uses the MTP. Many of the other leading manufacturers do use MTP. So hope that helps.
You can plug one into another.
Yes.
Correct? All right. James wants to know if we were talking a little bit about these extra fibers that are not terminated in the MPO, if we could move them to another connector like an LC or an SC or an ST. I guess we could. Again, I don't know what the practical application is, but I'm sure there's people thinking about that.
Yes, that's kind of what I was referring to earlier, actually. That you could.
Right. Chris wanted to know, will eight-stranded fiber become more prominent?
8-stranded fiber itself?
Yep. Yeah.
That's very possible. I guess I'm not a cable manufacturer, but that's very possible.
Okay.
Haven't seen it yet.
Tom would like to know, with electronics and technology growing so fast and so far, will the new standards be reviewed more often? Do you see a pickup in the standards process to keep up with technology, Gary?
Good question. Probably. That's hard to tell, but I think we've already kind of seen that a little bit too, as I mean, for example, just even on the IEEE, the 100 gig, right after, not much after that was ratified, they already started talking about, what do we do next? And so I do see that, and you're starting to see a little more alignment with IEEE and TIA in terms of the timing. Copper, for example, that copper one I was talking about, they're both kind of on a similar track, because that's what it's all about. You don't want TIA to develop a new standard, and there's no application that needs it, right? So it's having those tied together better. I think you're starting to see that more, and you probably will more.
Okay. There's been several questions wanting to know about getting a CEC for this presentation, and yes, there is a CEC available. Everyone on the call will get an email with instructions on how to get your CEC certificate. So, Charlotte, there is a CEC, and you'll be able to get it. Just pay attention to your email, and instructions will be forwarded your way. Let's see. I think there might be another question here. A lot of thank yous. And I think it's important that we do thank you. It was an awesome presentation. I think that The knowledge that was imparted here was very top of mind with the folks that were on the call. We had hundreds of people on the call, so great information. I want to thank Leviton for their participation in this event. Look forward to seeing many of you on additional G2 Talk seminars in the future. We enjoy doing them. We do one regularly the third Thursday of every month, but we scatter some others throughout the month. So stay in touch with us, and we'll show you those. They always show up on the event page at graybar.com. And again, Gary, thank you for your knowledge today and sharing that with us. It was a great presentation. And with that, we'll close out. You all have a great day.
Thank you. Thank you, everybody.